In today's class, we shall see about an introduction to cryptographic techniques. So, classification of encryption techniques are as follows. The first and foremost is plain text, which normally we call it as the original message. The second one is ciphertext. The original message is being converted into a coded message so that it cannot be viewed by a third party. Third is encryption. It's just converting your plain text into a ciphertext. Decryption is the reverse process of encryption. Cryptography, we use many schemes for encryptions. Such schemes are called as cryptography cipher. So this is the block diagram. So wherein it tells you about you have a plain text. That plain text has to be converted by using an encryption algorithm. As such, AES is the algorithm that is used, and there is a secret key that should be shared between your sender and receiver. So it is just an example as how normally we close our door and we give a key. We have an original key and the duplicate key is shared to our parents, and as soon as they come back from the office they'll be able to open the door. So as such, in the same way we can find that this plain text is being converted into a ciphertext by using an algorithm that is called as an encryption algorithm, and it is transmitted. This is called as a ciphertext, and while receiving at the receiver end, the secret key which is being shared by the sender is being utilized over here, and it is used to open it, and the reverse process takes place in a decryption. That is, your ciphertext is being converted into the plain text, so that is being received at the output. So here we have an expression which tells you that y is equal to encryption of k comma x. So k is the key and x is your, while you are sending a transmitted input, and at the output we get x is equal to d comma k comma y. So your d is the decryption and k is your key and y is the output, that is you'll be retrieving the message. So the conventional encryption, what are the requirements? So we should require a strong encryption algorithm, just like how we create a password. So it should be strong enough so that no one will be able to break. But even though we find that there are people who are intellectual, who are able to break our password. Okay. So here it tells you that the encryption algorithm which we are going to write, it should be a strong one. Sender and receiver must have obtained the copies of secret key, and it should be kept in a safe and secure manner. Next we can just see the block diagram. So in this block diagram, when we visualize, we can see have a message source which is your x, that is given to an as an input, and it is being encrypted by using an encryption algorithm, and you have a secret key. Okay, that secret key which is being represented as k, and after encrypting using an encryption algorithm we get an output y. So that is being given to a decryption algorithm. So the reverse process takes place and we get the original x that is being received at the destination. So next slide we shall see about the cryptography systems, and there are two types. One is the substitution mode of operation and the other is transposition mode of operations. So the number of keys used during operation symmetric. So wherein you can say that same symmetric, it tells you that it is same. Is it say maybe a single key or secret key? If both use that same key, we call it as symmetric, and asymmetric key is one, and the sender and the receiver will be having a different key. So the way in which the plain text is processed, so we call it as a block cipher. The input in one block of element at a time produce output block for each input block. A stream cipher, it processes the input and produces an output one element and it goes along. So these are the various types of attack. in the left hand side you can find. So you have ciphertext only. So you have a known to cryptanalyst. So ciphertext only, so where you use an encryption algorithm ciphertext. And the next one we can find that you have a known plain text. Again you use that same technique which we have seen in the first row, encryption then ciphertext, or you can use one or more plain text ciphertext pairs. Next is chosen plain text. It's the encryption ciphertext is repeated once again, and you have the plain text message chosen by cryptanalysts together with its corresponding ciphertext generated with the secret key. Then we have chosen ciphertext, encryption algorithm. Next is ciphertext. Next is ciphertext chosen by the cryptanalyst. Next we have the chosen text. So we use an encryption algorithm, ciphertext, plain text message chosen by cryptanalyst, which is put together with its corresponding ciphertext generated with the secret key. So these are the various types of attack and known type of cryptanalyst. Next we shall go for the substitution techniques. So as such there are four types. One is a Caesar cipher, mono alphabetic cipher, Playfair cipher and Hill cipher. So we shall see the cases cipher. So it's a very simple concept where what we do is we just replace each letter of alphabets with letters standing 3 places further down the alphabets. Say for example, we can just consider a plain text having a text message, meet me after the toga party. So how that has to be converted into cipher is the alphabet followed by 3 letters. After M we have NO, then we have P. So your M is being replaced with P, and you have E, F, G. After that we have the third letters as H. This is how is being the plain is being converted into cipher. Okay, and the expression for that is cipher is equal to your encryption P is equal to P plus 3. So P plus 3 is nothing but the alphabet after 3 places, and it is mod of, you have 26 alphabets. So we write it as 26. So this is an just an expression which is given for general cipher algorithm. So C is equal to EP from the encryption side, and this forms our expression P plus K mod of 26 for encryption. And for decryption, P is equal to your plain text, that is D is your decryption of C, which is equal to C minus K mod of 26. Next slide we shall see key for substitutions. So another method for key for substitution, you have say a text which tells you that PHHW, PH for instance. So that key, what shall we do is, before P what is the letter we have? O. Before H what is the letter we have is G. This is the technique that is being followed for this particular case. Next we have the mono alphabetic cipher. Here it gives you a certain types of you have an 26 alphabets. So it is being determined in terms of percentage, and we have to match by seeing this, we have to match which is approximately equal to. Say for example, I just show it in the other next slide. Say for example, P is approximately is equal to E. Say for example, here we can find that P is 13.33, and you have it is equal to E. Say E, you can find it is 12.7%. So more or less it is approximately equal. So next we shall see the next one. Z is equal approximately equal to T. Okay, here you can find your Z value is, say for it's 11.67, and here you can find T. Okay, T is equal to 9.1, which is more or less approximately equal. And the last one you can see SA. Okay, here you can find that S is 8.33, and SA, isn't it? A. Okay, so you can find that A is 8.2. So we just match it according to their percentage. Next we have Playfair cipher. So this Playfair cipher is just a 5 by 5 cross 5 matrix of letters, constructed using a keyword matrix. So you can write the row from left to right and top to bottom when you want to decode it. Okay. Next is Hill Cipher. This is a purely mathematical method and a multi-letter cipher developed in the year 1929. So encryption takes m different successive plain text letters and substitutes for them m cipher text letters. Next is transposition techniques. So transposition techniques, there are two techniques that is used. If suppose I want to write a message, it should be written in a rectangular form, row by row. Okay, and to read the message, you should read it column but permute the order of columns. Okay, so you have to permute it in a ascending order. So I'll just give you an example so that you'll be able to understand. Plain text. So this is the plain text message that is given. Attack postponed until 2 am XYZ. So the key that is given is 4312567. Okay. So we can just write that same key 4312567. So you can just write the, as in the first point is shown that you write a message in a rectangular form row by row. So I just write it as ATTAC and then followed by P, okay, KP. Next is next you can find you have O, then you have OSTPONE, then next is after you have D, DUTILT, then at last you have WOAMXY. Now what you do is when you want to read the output, so write the output. So what shall we do? We should number it in an ascending order. For example, 0 to 9. So 0 to 9, here of course there is no 0. So we can consider 1. Say we have TTNA. So that is what is written. Next is 2 APTM. Then we have 3 TSUO. Next is fourth one is AODW. Next is fifth one COLJX. And you have sixth one KNLX. And at last you have the seventh one PETZ. So this is how your substitution takes place. Okay. Thank you all.